Let's solve the integral of 1 over the quantity x minus 3 times the square root of x minus 1. The domain of this integral requires x to be strictly greater than 1 for the square root to be defined and real, and x not equal to 3 to avoid division by 0. Strategy for this integral. This integral contains a square root term in the denominator. A common and effective strategy is to use a substitution. Let u equal the square root of x minus 1. From u equals the square root of x minus 1, we square both sides to establish a relationship between u squared and x. Squaring both sides gives us u squared equals x minus 1. Now we need to express x in terms of u. We can rearrange the equation u squared equals x minus 1 to solve for x. Adding 1 to both sides, we find that x is equal to u squared plus 1. Next, we must find the differential dx in terms of du. We differentiate the expression for x with respect to u. The derivative of u squared plus 1 with respect to u is 2u. Therefore, dx is equal to 2u du. Substituting into the integral. We substitute x equals u squared plus 1 into the term x minus 3. This becomes u squared plus 1 minus 3, which simplifies to u squared minus 2. The square root of x minus 1 is our substitution variable, u. Substituting all these parts into the original integral, we get the integral of 2u du over the quantity u squared minus 2, multiplied by u. Notice that we have a factor of u in both the numerator and the denominator. Since our domain requires x1, u equals sqrt, x1 must be strictly positive, so u is not 0 and we can cancel these terms. After cancellation, the integral simplifies to 2 du over u squared minus 2. Integrating the rational function. This integral is a standard form. The integral of 1 over y squared minus a squared with respect to y is 1 over 2 at times the natural logarithm of the absolute value of y minus a over y plus a constant of integration. In our integral, the variable y corresponds to u, and a squared is equal to 2. This means a is the square root of 2, approximately 1.414. We apply the standard integration formula. Our integral is 2 times the integral of 1 over u squared, minus the square of the square root of 2. The formula gives us a factor of 1 over 2 times a. Applying the formula, we get 2 multiplied by 1 over 2 times the square root of 2, times the natural logarithm of the absolute value of u minus the square root of 2 over u plus the square root of 2, plus the constant c. Simplifying the coefficient, 2 over 2 times the square root of 2, we get 1 over the square root of 2. So the result is 1 over the square root of 2 times the natural logarithm of the absolute value of u, minus the square root of 2 over u plus the square root of 2. Plus c. Substituting back for x. Now we substitute u back with its definition, the square root of x minus 1. The integral evaluates to 1 over the square root of 2 times the natural logarithm of the absolute value of the square root of x minus 1 minus the square root of 2. All over the square root of x minus 1 plus the square root of 2. Plus the constant of integration c. We need to be mindful of the absolute value. The argument of the logarithm must be positive. Since the denominator, square root of x minus 1 plus the square root of 2, is always positive for x1, the sign depends on the numerator. If x is greater than 3, the numerator is positive. If x is between 1 and 3, the numerator is negative. Specifically, if x is greater than 3, then the term square root of x minus 1 is greater than the square root of 2, making the numerator positive. Conversely, if x is between 1 and 3, the term square root of x minus 1 is less than the square root of 2, making the numerator negative. The absolute value ensures that the argument of the natural logarithm is always positive, which is required for the logarithm to be defined. Common mistakes to avoid. A common mistake is choosing an incorrect substitution, like just u equals x minus 1, or incorrectly calculating the differential dx. Always ensure consistency between substitution variables and differentials. Another frequent error is misremembering the standard integral formula for 1 over y squared minus a squared. Specifically, students might forget the 1 over 2 a factor, or the absolute value around the logarithmic argument. Remember, the correct formula involves the 1 over 2 a factor and the absolute value in the logarithm. An incorrect formula might lead to a wrong antiderivative. Related mathematical concepts. The integrand can be viewed as a rational function of the square root of x minus 1. This structure directly suggests making a substitution for that square root term. The integral of 1 over the quantity x minus 3 times the square root of x minus 1 is 1 over the square root of 2 times the natural logarithm of the absolute value of the square root of x minus 1 minus the square root of 2 over the square root of x minus 1 plus the square root of 2 plus the constant of integration c. This result is valid for x greater than 1 and not equal to 3.